Good evening. We're going to wait for a couple people to get back in or get into the webinar, and we'll get started shortly. Welcome. My name is Amy Chow, and I will be the moderator for tonight. We will be talking tonight about real-world curve fitting with ClassPad.net. That is a tongue twister all the time. For the sake of webinar quality, we're going to keep everyone muted and all videos turned off. If you do have a question, you can type it in the chat panel and I will try to respond back to you. Or if not, I will ask Karen, who is presenting tonight, to answer the questions in the entire group. You can certainly message me in private, or you can message everyone so that everyone else can see the question as well. That's probably the best way so that we're not getting like repeat questions. And just before we start, we just wanted to give a little bit of background about each of us. Karen, if you'll move to the next slide, thank you. As I mentioned, my name is Amy Chow. I am currently the Training and Product Manager at Casio. My main responsibilities are on the screen, coordinating workshops for schools, districts, and conferences, as well as working with our development team on calculator updates and improvements. And I'll let Dr. Karen Greenhouse introduce herself.
Well, hello, good evening, everyone. Thanks for joining us. I'm Karen, and you can read my blurb, but currently I teach in Drexel University in their online math master's program. So I do that pretty much every semester. I have some courses, and then I'm also consulting for many different things, but one of which is Casio. So I've been working with them for about almost 6 years, and I am going to be sharing some math things that I've been doing with ClassPad.net. So I'm going to get started, and let's see, Amy, tell me if my screen switched. Did my screen switch?
Not yet.
Okay, so I have to change my sharing. So let's switch my screen. How's that?
That works.
Okay. All right, so I'm working on ClassPad.net. I'm not going to spend a lot of time telling you what it is. You're going to kind of see what it is for those of you who have not been exposed to it before. But it's a free online website, math software. You can pretty much do infinite possibilities, as it says here on the web page. Pretty much any math you want: calculation, graphing, geometry, statistics. So you're going to see a lot of that in what I'm doing tonight. But my goal this evening is to show you how you can use images, real-world images, in many different ways to help students apply the mathematics and kind of learn the mathematics and see how it's connected to real world. So my goal here is to first kind of give you some examples of what I mean by real-world curve fitting and showing you how some images are used in activities that are already created. So the first 4 activities are ones that are already done. I have them. I'm going to share them in the chat panel with the URL. So with ClassPad, when you create activities, if you have an account, you can just play on ClassPad if you just want to play and do math, do a calculator or do a graph. You can do that without having an account at any time, students as well. But if you have an activity, if you find activities, we have tons of activities. You'll see up here on the website, there's this activity links. We have tons, hundreds of activities now that you can search. And if you find an activity and you want to keep it and save it, then you need an account because it needs to know where to put it. So I would suggest everyone get an account. It's completely free. You'll notice down here it says the Plus Suite is available till August 31st. All that means is the extra things like the CAS system, so where you could solve an equation or factor a polynomial, those types of things are extra apps in a sense, and then the AP Stats. But everything else is completely free all the time. So I would suggest getting an account. What I'm going to do is share 4 activities first, and then I'm going to show you how you actually insert images into your activities so that you kind of see how you can do it. Lots of things you can do with the images. And then I'm going to hopefully have enough time to show you some other interesting things that you can do with images, because we can also insert animated JPEGs, or animated pings is what they are, where you can actually have movement in your activity. So hopefully we're going to get to everything. At the end, I'm going to share a file with you that has links to everything. And if we don't get to them, it has links to all the activities. So the first activity, I just want to kind of just show you some examples. So that's how we're going to start. So I'm going to, in the chat panel, I'm sending you a link if you'd like to play along. You do not have to. You can just enjoy and watch, but if you'd like to play along. This first activity is one where it's an algebra-based activity where they're doing line fitting, right? So this image is an image from my personal things when I went to Milan. This is in, I forget what the name of the building is, but it's a picture I took. And so I uploaded it. And so now here's this image, and it's done in the graph sticky. So I'm going to click on this. And so this is a graph sticky. So there's two places in ClassPad where you can insert images. You can do it in the graphing sticky or the geometry sticky. And I'm going to show you both so that you see the difference. When it's in the graph sticky, you can plot points on top of it, and you can put functions on top of it, and you can use it to help students, you know, do the slope, those types of things, or quadratics, whatever it is you're doing in the graphing situation. So in this activity, I just wanted to show you, it's telling you to click on the points and enter some points. So I want to point out for those of you unfamiliar, this is a graphing sticky, and I can do a function. I can plot some data, images, which I'm going to show you how to do. That's what this is. Or I can plot points. So here's this image, and this activity is asking students to plot points on top of the image. So they're going to get a plot point. And this is the default color, which is blue. And I'm thinking blue is not going to show up very well in here. So maybe I'm going to go to the settings. So the three dots, whenever you see three dots anywhere on ClassPad, that means settings. I'm going to change it to a color that might stand out a little bit better. Let's say orange. So now I'm going to plot some points. You could have students actually, you know, kind of look at the grid and try to plot specific points, but my suggestion is just have them plot points randomly. So I'm just going to make some points up, and I don't know if orange is the right color. Can everyone see the points coming up? I'm just plotting them in random positions right now. It's not the best color. We might have to change the color. And I think they're told to plot at least 5. So I have 5 points, and it doesn't matter. The nice thing about this, it doesn't matter where I plot the points. Now I'm going to be able to move them anywhere I want. And you'll notice as I move the points, they change here. So I'm going to click a point, and the activity says find a line. And notice there's lots of lines that they could pick. And so I'm going to choose this line right here, and I'm going to put the point on the line. So notice as I move the point, its coordinates also change. So let's just pick a couple positions on this line that I am attempting to make a equation for. So they plot the points. So you'll notice that the coordinates are for each point are showing up, which is nice. And now the question is, okay, how could you use these points to actually plot a line, find the slope of this line? So here's where you can then pull up a calculate sticky and say, okay, well, let's say if I want to find the slope. So I'm going to use the coordinates of 2 of these points. And so students could pick whichever 2 points, you know, they want. So I'm just going to pick these 2 right here. So I'm going to find the slope. I'm going to calculate the slope. So I'm going to use this point right here. So I'm going to get so I'm going to calculate sticky. Those of you who are not familiar with ClassPad, when you click anywhere on the screen, here's all your options. So calculate, graph, geometry, data, sequences, finance, and text. So here's an example of a text. This purple thing is a text box. This is a graph. This is a calculate sticky. So you pretty much can do whatever you want. And then once you've done it, you can move it and rearrange your paper. So I'm going to do a calculation of slope by using these 2 points right here. And I want to use my fraction template here. So I'm going to do negative 2.69 minus negative 3.5. Yes. Oops. Wow. That doesn't look good.
I was going to say, Karen, that's
I don't know what I was
do.
doing. I don't know what I did there. That was not good.
Oh.
And yes, I know I should use parentheses, but oh, why is it doing that? Sorry, I'm having user error right now. There we go. And it was negative 5.6 minus negative 6.5. All right, so the slope of this is, and so I'm in my account, so it's going to do my standard notation or my decimal, so I could use either one. Obviously, I'm going to use 5/3 because I like my slope to look like a slope there. So now I can actually now plot a function to line up on this line. See if I can plot it using my point. So I found my slope down here. So
Karen, I don't know if that slope is quite right. You missed the 0.69.
Did I miss a point?
Yeah, from the
Where?
-2, the very first.
Oh. Where did that come from?
I know.
2.69. There we go. Thank you, Amy. All right, now we're going to be even better. Okay, 9/10. You're right. That makes more sense. So now notice graph sticky, I can plot a function. So all of this is connected. Oops, I really zoomed in there. There we go. And so now I'm going to use that slope that I just calculated and plot my function. And maybe we want to change this to match the point. So we're going to change its color to be orange. And now I'm going to do y, and let's do point slope form. That makes sense because I have points. So this is where you really help students kind of understand which form makes more sense depending on what it is you have. I have points. So let's choose another point on our line. Let's use this one. So y minus, and let's use parentheses here, -1.06 equals the slope that we just found of 9/10. And I didn't use the template. I could have used the template here, but when I'm on my keyboard, I tend to just use the backward slash and it makes the fraction right away. So x minus -3.7. And so now, hopefully, if I did everything right, so I'm a student, I've been trying to find a line, and it should go through there. And so then you could ask, should we limit the line? Are there limitations on the line? But this is now using a real-world image to kind of understand how lines work. If you think about this shape, this image right here, I could have also done some geometry on it because it's got a lot of circles in it, and I could have done angles and concentric circles. So maybe I would have wanted to put it in the geometry sticky as well. So there's lots of options, and I am going to show you some examples of images in geometry as well. So this is just a quick example of why you might use images and how they can help you, apply the mathematics that students are learning. So I'm going to go to another one, and this one, I'm not spending a lot of time on this one, but I'll share the link with you. So this one is just an example of using images to help students make sense of definitions. So we're talking about slope in this activity, and a lot of students don't understand what slope actually means. So we're using these images as a way to describe what slope might mean. So you'll see that this is a mountain climber, and he has to get from point A to point B, and the slope, the steepness of this mountain represents the slope that he has to climb. How steep is it to go from A to B? And he's going up the mountain, so that relates to the positive slope. So these images are being used to help clarify the definitions of the words that we're using in mathematics. And so this road sign is an image that was inserted, and it also describes slope, but it's showing the car going from point C down to point D, so it's going in the opposite direction as the mountain climber is, and he's going down, so it's negative. So I'm using images here to help clarify a definition of math. So not necessarily finding the lines, but really more as a descriptive way, a way to help them understand some of the mathematics that we're talking about. So that's sort of what this activity is about, is this is slope, this is a positive slope, this is a negative slope, this is how it relates to the real world. So notice in this, I wanna click on it, I actually used a geometry sticky this time. So in the last activity, I'll just show you the difference again. This was a graphing sticky, and you can tell the difference because a graphing sticky has the function, the data, and the plotting points. A geometry sticky has geometry tools down here. So that's how you kind of can tell which sticky you're in. So I used a geometry sticky in this one because I could draw lines to kind of fit on top of my images. So it sort of depends what you want to do with your images, which sticky you would want to insert the image in. Do you want to do it in geometry, or do you want to do it in graphing? It depends what it is that you want to do. If you want students drawing on top of your images, then geometry is often the one that you're going to use. If you want them moving points and plotting points and finding functions, then graphing tends to be the ones that you use. I'm not going to go on to this activity because this activity then goes into actually how to find slope and things like that. I just wanted to show you different ways that images could be used to help students understand the mathematics. So I'm going to do 2 more activities, and then I'm going to show you how to actually get these images in here. All right, so this activity is a introduction to translations by coordinate rules. So using an image to kind of help them see what's happening. So this is an image of a bunny, and they have the bunny's nose is at the 0 point. So they're basically following the nose, right? And this, I'm just explaining what has happened with this image. I am going to show you how to do this, so don't panic. But this image was inserted using sliders. And the sliders allow me to move the image, and these sliders were designed specifically to be horizontal and vertical. So H for horizontal and V for vertical, because we're talking about translation. So if you haven't guessed it, this was done in a geometry sticky. And again, when I click on it, I know it's geometry because here's all my tools down here, all my geometry tools, because geometry allows me to, you know, do a lot of different things. Now you'll notice it looks different than this geometry sticky. This geometry sticky didn't have any grids. This one does have a grid, so it almost looks like the graphing sticky, and that's because you can turn the grids on and off in both of those stickies. So in this geometry, I turned on the grid. I even put a minor grid in here so that the little small lines in between would come up. So there's lots of ways you can make them look very similar. So I needed a grid because we're talking about coordinate transformations, coordinate translation. So I'm going to just tell you what this image is. I have an image of a bunny, and I actually have it on there twice. One of the images is static, it's going to stay, and one I put inserted using sliders. And the reason was I wanted them to watch what happens. Now it's not ideal because the image actually has a white background, but watch what happens. I want students to kind of watch the bunny's nose. Here's the bunny at 0, 0, and if I move him to 6, what happened? So here was the original bunny, and here's the new bunny. Where's his nose now? And so his nose is at 6, 0. So what did a horizontal move do? It changed the 0, 0 to 6, 0. So a horizontal move adds to the right, adds value to the X, right? And so you could have the students conjecture, well, what if I wanted the bunny to move to the left? What would I have to do to the original image? Well, you would subtract. So that's sort of where we're trying to go, but in a fun way with a bunny. So that's a nice thing. And now I can also move up. So now they could conjecture if I want the bunny to move up, I'm going to add to the Y value, the vertical. So let's move the bunny up 6. And if I want him to move down, I'm going to, you know, go left, go negative. And so now you could set him back to 0, and you could ask the students, okay, if I want the bunny to end up at, you know, a specific coordinate, you know, maybe put a point on the grid somewhere. So this is where the geometry comes in. If I want the bunny's nose to end up here, how would I have to move them? And so it's helping students understand the translation rules. You know, you have to add, subtract to the X and the Y. That's what we're doing with this activity. But this is just an example of how I actually use the same image on top of itself, but one of them is being controlled by sliders, and one of them is being controlled by its, just by itself. It's a stationary. And again, I'm going to show you that in just a minute, but I'm trying to give you examples of things that can be done with images here. I'm not going to go further into this activity. Did I share this activity with everyone? I don't think I did.
No, you did not. But it's going to be on the PDF at the end.
It's going to be on the PDF, so we'll get to that. So here's another one. And again, the ones I'm sharing with you are not, I'm not sharing the whole activity. I am really trying to just concentrate on how are images being used to help us understand the mathematics, fit curves, those types of things. So this activity is about scale and perspective. And you'll see here's an image that has a room in it, and they can fit the line. So again, notice it's in a geometry sticky. It's a static image, doesn't have any movement in it, but I can now fit segments to it and measure those segments and basically, you know, come up with the scale for this room. Like, so how big is this living room in reality? I can measure my segments that I could draw on it or my little pieces and do a scale conversion. So I am fitting the mathematics into the image that I have there. So this is a nice activity, like curve fitting using images just on top. But additionally down here, it also helps, this one's all about dilations and, you know, scale. So this one is an image where I am kind of helping students understand dilations and perspective. So this image is, you know, a road, and this has got a segment on it. So again, we're in a geometry sticky. It's got a segment on it, or rays actually, that show perspective. And then the original image, which was done with a polygon tool, has been dilated by a scale factor, and the scale factor is controlled by this slider, and it makes the house, image of the house, get smaller and smaller as it goes towards the point of dilation, and larger as it goes away from the point of dilation. So it's just helping students understand perspective and how dilation works, but using an image to kind of, you know, a house on a road. If you wanted to make the house look like it was at the end of the road, you would be scaling it down, those types of things. So again, connecting real world. So before I move on, these are just examples of how images can be used to help students understand some mathematics and, you know, apply the mathematics they're learning to real world things. I'm going to show you how to do that now, unless there's some questions before I move on. Nothing?
No, I don't see any questions.
All right, so I'm already signed into my account. If you don't have an account, just the difference being this activity I was just using from the URL, like you guys have, which means it opens up in technically as a guest. And so you'll see that there's no little cloud here because technically it's being used as a guest. So if I do any work on it, it's not going to be saved unless I duplicate it to my own account, and then it becomes part of my activity. So the difference being this paper right here, I'm starting a new piece of paper to show you guys how to insert images, and I'm in my account and I have this cloud here, and that means any work that I do is now going to save automatically. So that's a really nice feature. You don't have to ever think about saving because it's doing it constantly. So what I wanted to show you is how do you get these images in there and how do you work with them? So again, two places that you can do images. So let's look at graph first. So you want to open a graph sticky, and that's this one right here. So click anywhere on the screen, look at your options, choose graph. The graph default is to always have a grid. That is the graphing default. Settings up here, the three dots, you could turn the grid off if you want. I'm going to leave the grid on for now. So when I decide, oh, maybe I want to do, I don't know, sign or like some curve fitting. Let's find an image that is a real world application of something that I'm studying. So first you have to find your image, and your image needs to be, I think it can be a PNG or a JPEG. I tend to use JPEGs, but it needs to be an image that you have on your desktop somewhere. You can't copy and paste into this at this moment. We're still working on that maybe, but you have to have an actual JPEG picture file somewhere on your computer. So when you have that, if you look down here at the bottom of the graph, you'll see this little image icon. When you click it, it says, okay, we're ready for you to drag a picture in here or go to a file. I tend to just go to my file. So I'm going to click on the space here, and it's going to take me somewhere. And I already have a file for today that's already up there, webinar images. And so I'm going to go to this one first. I don't know that we'll get to all of these, but I'm going to go to this one. So all I have to do is when my image is, and notice this one's a ping. So we've got a PNG file and then JPEG files, JPG. So either one of them works. So I'm going to click this one. And when you click it, it puts it in here, and it kind of gives you a little information about it. And then you say OK. And it automatically centers it at 0, 0. So you'll see this is the image descriptor. And so now here's where you can think about what is it you want to do. So one thing that you can do is, do you want it in the back of the grid? So notice how the grids are kind of on top of the image, or do you want it in front of the grid? So that's sort of up to you, whatever makes you happy, whatever makes you, looks good. I actually kind of like it right now on front, so I'm going to leave it on the front. But obviously, depending on what you want to do, if I want them to try to maybe make a regression to fit this curve somehow, I don't like where it's positioned. So you can change its position. You can even change its size by changing the numbers here. So right now it's at, I don't mind the center at 0. I kind of like that, but I kind of want it to move up. I want to maybe look at this sitting on the X. So I've got to figure out how far does it have to go? Well, this piece right here, I want to go up to 0. So it looks like it's at maybe 3.5. So let's change the Y. So you can play around with position just by changing numbers. So that's pretty close. Maybe 3.4 was a little better. So now I'm on a graph, and I kind of, if I want to move like where the graph is, maybe I want to move it down. In the graph, all I have to do is click on it, hold my mouse down, and kind of move it. So I'm going to move this down just a little so it's a little more centered, and I'm zooming. By moving my mouse, I'm zooming out a little bit. So here's what I want. So I want the students to plot some points here, and then let's figure out a regression and to figure out a function. So that's sort of what my goal is for this activity. So graphing made sense for me to put this image on here. So if I want them to plot some points, and I'm not going to do the whole thing, but again, to plot points, all I did right there was choose the plot points, and now I can just, make some random points. I tend to always do them in a row just so they are easy for me to figure out, and then I move them after. So let's do at least, oops, not 17. And then now I can fit that, whoops. Now I can move the points and fit them on the curve. I could do it this way. I could do it doing plotting points, but if you do plotting points, then you can't use the statistics menu. So I'm going to now show you another option that you could have also done. So I'm going to delete this, so notice all my points go away. So instead of plotting points, I'm going to actually use data. And it starts off very similar, except you won't see the points plot. So I'm just going to plot a bunch of points here. So let's do it -1, 0, 1, 2, 3, 4, 5, 6. So notice no points showed up, and that's because I'm in data. So in data, you have to enter your data first and then just tell the calculator what you want. So this is now showing you, those of you who have not seen ClassPad.net, I am now doing statistics. So I'm doing graphing, statistics, all in one place. And so when I click the two columns, I can now plot a scatter plot. And so there's my points. And once the points are on there, now I can move them. So let's just move them to some strategic positions here. So it kind of depends, your students doing it manually. Do you want them to be able to use the statistics menu to do the regression automatically, which is what I'm about to do in a minute here. Did I get all the points? I think I missed one. All right, so let's say I do this. Here's my points, and now I want to use the statistics options to do a regression instead of manually. So when I click on this again, I'm going to go back and look at my regressions. And if everyone wants to, who wants to tell me which regression do you think is going to be a good fit for this particular curve? Anyone? I don't see any.
Sine.
Oh, Tom is saying sine. That's the one I was going to go with too. So when I hit it, because I'm in statistics now, I'm not doing it manually. It's doing, so it's not exactly right, but it's pretty close. And so now you would notice when I hit that, now here's my function, right? And so what the students could then do is where is that? There it is. Take this regression and write the function out here and then try to fit it a little better than this regression because it's off a little bit, right? So they could, play around with the numbers, try to make it fit a little better. And that's what you want them to do is to, how could you manipulate these coefficients to make this function fit a little better than it does right now. And once you do that, then you can, I'm not sure if this does it. You could also do the integrals once you're done and do, let's do area under the curve. So, well, let me show you now that I have it. Let's do a lower bound and an upper bound of 4. And that is a terrible color, so it's not showing up. Let's do it in red. There we go. So you can also now do your integral and your area. So this is where an image of a real thing, a roller coaster, is really kind of applying to what they're learning in. This would be what, Algebra 2, I think. So just an example. So I'm going to scroll down again, and now I'm going to show you geometry. So adding the images is pretty easy. What you decide to do with it is up to you. So I chose graph for this one because I wanted to do things like a regression and some statistical plotting and some integrals. But let's say I now want to do some curve fitting with geometry. So I'm going to go into the geometry sticky. So notice geometry is a blank screen. In settings, I can turn on the grids if I want, but right now I don't want a grid because I'm doing geometry, and I'm going to actually turn off auto labeling. So this time I'm going to go get an image. So the image is in a different location, obviously, because we're in geometry. So images, to get the image icon in geometry, you're going to go to this text one, and when you click it, there's other options. So here's the image. It looks exactly like the one that was in the graph, but it's just in a different location. And protractor, we have a protractor too. So I'm going to click image, and it looks the same, right? It's the same situation. I have to drag a picture in here or go find one. So I'm going to click again. It's going to go back to the folder that I was in. And I'm going to choose this one, which is an example of a piece of pottery found in an archaeological dig. That's a very hard word to say there. And so the idea is, what did the whole plate look like? Can you get the, how big was this circle? What was the diameter of the circle? Things like that. And so notice this, it automatically is centered. Even though you don't see the X and the Y, there is that underlying grid, and it's centered there. And I'm okay with this being exactly where it is. If I want to move it down here a little bit, because I'm trying to do the whole circle, I can do that as well. But here's where you can now do this. This is geometry. So what I want students to do is to put things on top of this image, to draw things on top and fit the curve. So maybe do an arc. Or so let's get the arc tool out here. So this is why I chose the geometry over graphing, because I can draw on top of it. So if I do an arc, oh no, let's not do an arc. The arc requires you to know where the center, well, it doesn't matter. Let's pretend the center's here. I'm not quite right? So it was a bad center. But now I can adjust my arc. So that's one way I could do it. I kind of don't want the students doing that. That's not what I really wanted them to do. So that's one way. So that's where we think the center is. Another thing that I would, if I were actually doing this with my geometry students, is to do chords on the curve. So let me undo what I just did. And I would actually say do a chord. So let's do a chord from this point to this point. And let's do another chord, because these are all concentric circles, it looks like. Let's do another chord from this point to this point. And if they know their, oh, actually, it should probably be on the same circle. If they know their rules about geometry, they could find the perpendicular bisector, and they intersect at the center. And that's how I would find the center of the circle, and then I could do the circle. So again, I chose geometry because it made sense for the picture that I was importing. I want to show you a couple other things you can do with images, and then I'm looking at my time here.
Yeah, about 20 minutes.
I see
25.
that.
Yep.
I'm trying to remember which one, what I want. Oh, I'm going to do geometry again because I want to show you some things that you can do to kind of change things. I'm going to use geometry again. And I'd like to go in here and turn off the auto labeling because I just don't like it. And I'm going to get my image. So remember, geometry, image is under the text, picture. And this time I'm going to do, I think that's the one I want. My number spinner. All right, so there's my number spinner. And let's say I'm talking about rotations, right? So I want to rotate this. So I might decide that I want this to be, is that what I want? I'm trying to remember what I wanted to do here. Oh, so notice you have I'm fine with the center 0 and I'm fine with the center Y, but instead of an angle of 0, I want the angle to be something I can change. And this is where it's really cool in ClassPad. You can use variables, letters to change things. So I'm going to change, instead of 0, I'm going to make this have an angle of A. And A is a variable, so the minute I put in a variable, what happens is it creates a slider. And so now I can control, I can move this image because I put in a variable that creates a slider that moves it. Now, if I'm thinking about angles, I might want to change my parameters here. We want it to go clockwise and counterclockwise, so maybe I want to be -360 and +360. So this is just a slider that you can change the range, and you can also change how it steps. So maybe I want to step by 1, angles of 1. And so now I might say, what happens if you go, and these represent degrees, if you turn, 230 degrees, where's the 1 end up? You could put a coordinate grid on here if you're thinking about angles of rotation. So maybe adding a grid would be a good idea, and numbering it. So now I have a grid and I can, oops. So how far, let's go back to 0, because 0, remember, was our start position. And why does 0 not exist anymore? Sorry, I'm not being very precise here.
Can you type in the number value for A instead of using the slider?
I guess I could.
So that's another way to get it a little bit more precise.
I just don't know why it's not on the slider.
Yeah,
okay,
sometimes it's weird too, but.
Yeah, okay, so here I am at 0, and let's say I tell the students, okay, I want this left side of this one wedge to be in where this left side of the 2 wedges, what angle of rotation would I have to move it? And they can test around like that. So there's lots of things you could do, but you can control your image now by a slider, which is really nice. So that was just another thing that you can do. I wanted to now show you, I'm going to get the graph sticky out. So all I'm doing is showing you different things you can do, and then we're going to end with looking at some examples of activities that already have these things done. But another thing is you can actually kind of make some kind of fun activities, art activities, moving things on, what am I saying? On functions. So I'm in the graph thing because I'm going to use a function to define an image, to control an image. So I'm in the graph, and I'm going to hit image again, and this time I'm going to get my frog. So here's my frog. And just as a general thing, because the graph and the geometry both have white backgrounds, I always try to find images with white backgrounds. So because if not, so technically this whole image is in the picture. So it's not just the frog, it's the whole square with the white. So if you have if you don't have a white background, you see that square. So I try to always find images that have, unless it doesn't impact what I'm doing. But I'm going to hit the frog, and he's huge, right? So I already know, I did this ahead of time, so I already know that I want to change his size. So you can change the width and height of your image as well and make it bigger, smaller, whatever it's going to work. So I want him to be kind of small. So I'm going to make him 2. And 1.76. And so notice he got really small there. And I do like him at the back, that's fine. So what I want to do is, instead of the center at 0, 0, I'm going to actually make it be controlled by a slider. So I'm going to move them. So I'm going to put an A, or you can put whatever letter you want. So I just happen, actually I can't use A because I use A already on this page. So let's use B. So I'm going to use B, and it's like, why is it not letting me? Oh, sorry, I forgot. I have to actually define this first. So I'm going to do a function and say y or x equals B. I forgot to do that first. And so now it says, oh, B is a value of x. So I should have done this differently. I defined x to be this function B. So basically just wherever B is. That created my sliders. And now I said the frog, I want him to be basically on the B. Now, I don't like this little blue line showing up in the middle of my frog. And so the nice thing about this is I have this function, but when when I click here, one of the options that you have is you can hide the actual graph. Like, so you'll still have the function, it's still there, it's still underlying, but you can hide so you don't see the line. So now I don't actually see the line that's controlling my frog. Now I'm going to go back up to my y, because I want to actually now put in a function. So I want the center, the y, to be a function sine of B. And so it's now moving based on sine of B. So watch what happens, and I think I'm okay with the 10. I'm going to change so that, notice how my range is from -10 to 10. I'm going to click on my graph and just do my zoom so that I can see my 10. That's just one way to do it. I could also go up into my settings and change my range and domain here, but I like to just use my zoom button. So here's my frog, and as I'm going to just hit the play button. So this is the slider. I'm going to hit let's make it step by 1. And now if I hit my play button, you'll see my frog moving, and he's moving according to the sine function. And I could actually graph the sine function. All right, so let's graph the sine function so we can see it. So I'm going to graph y equals sine of x. Oops, I didn't mean to. There we go. And then I could even tilt his angle a little so that he looks like he's kind of moving. So I can change my angle of my image so it kind of turns. So if let's put in a 10 and see what that does to him. So he turns just a little bit. That seems like enough. So now when I hit him, and I'm going to just animate him because you can see everything. So he's now animating along my sine curve. So you can have a lot of fun with your students making some different activities, because you can use variables. You have to define them. You know, x, I want it to be centered at x. I used a variable instead. And then you can use functions to control where your image is and how it moves, and sliders. So just different options that you can do with your images here.
It looks like he's actually hopping.
I know, and if I hid the graph, I probably should hide the graph. Or if I turned off, so one of the things I was playing with, like, let's change. Oh, I have to stop him, sorry, he's moving. There's fun things you can do. You can, if we change it to green, you could add like little equations of circles, put some lily pads in there. You could make, a lot of art going on there. I could make this be an inequality, right? And make it be less than or equal to. And now it's shaded in, so maybe pop it on grass or something. Maybe it should have been blue. So, but you can have fun with it because you can do a lot of different things with images controlled by, you know, variables and functions and those types of things. So
And one thing to note, can we hide some of this stuff? You know, if it's starting to get too busy, like if I'm creating as an educator or teacher, creating a lesson.
Yeah, so a lot of times what I do, if I don't want students to know that I did all of this, right now there's no way to hide, like up here and hide this from them. Eventually that's going to happen where there's a setting you can click where it's going to say hide it. But so right now there isn't. But what you can do, and this is what I always do, is if you put it under your graph and then click the graph, it stays under the graph.
Mm-hmm.
And unless you click image again, and then it'll come back up. And so like if you didn't want them to see this, you could hide that as well. So anything you put under it is now hidden, and like, so maybe you only want them working
to see the slider.
section,
Yeah.
right? So whenever you don't want something seen, right now the way to hide it is to put it underneath something, and it usually stays hidden. Eventually down the road, we're developing a way to actually lock and hide stickies and things so that you don't see them. So I wanted to end with just showing you just a couple more examples, and we're not going into all of them. I just wanted to show them to you because I have some calculus examples, and I wanted to definitely show you the animated pings. So let me just go into this real quick. So this right here is what we call an animated ping, and it's animation. It's allowed, you can only have up to 5, gosh, I can't remember what it is. Is Ish on? Is this here? No. He knows what it is. Darn. It's a certain, it's like a 5-second thing. It's only a short thing. So this is what I do, is I create little GIFs. I have a Camtasia Studio, and they're 5 seconds long. And then I go to a free APNG converter. It takes my GIF and turns it into an APNG because it will only accept APNGs for animation. But to get them in there, once you have that file, to get it in there, this is in the graphing sticky, to get it in there, it's exactly the same as inserting an image. You're just inserting an animated ping is what it's called. So this is an example of it, and students are, you know, they're watching this fish jump out, and so they have points. This is an already done activity. They have points, and they're just going to try and match the lines of where the fish is. Now, it does move fast. So it's a little hard, but it's still kind of fun, and then they fit the curve and see if they can find the fish. So you can do things like this. I tend to do these a lot. Like if I want students to remember how to do, you know, matrices or something, I might make a little animated ping that shows them the steps to do it real quick. But this is a fun way too. Bouncing balls or pendulums. I just did an activity with pendulums that were moving. So you can also add some real excitement to this, real things happening and curve fitting this way as well. So this is just an example. You will have the URL to that in the paper that I share. So that's kind of a fun feature. Here's an example of curve fitting with an image, and this is, you know, area under the curve. We sort of already did one of those, but notice everything's already set up. So the points are already here, and they're going to basically move them to fit the curve, and then they're going to record the points in the table. So this involves collecting data, then doing the regression, then doing the integral under the curve. But all the work is sort of already done for them, then students are just kind of moving and fitting the curves as they want. And then they're going to find the area under the curve after they've done the regressions and the integrals, those types of things. So this is a calculus example. So there's lots of, you'll see, those of you, again, new to ClassPad, these are text stickies. So notice that they come in a color. You can change the color of everything. So this is calculus. So calculus is obviously whatever color this is, orange, beige. And so directions, you can write directions for students. You can have them do data. You can have them have images and graph fitting and making, you know, doing functions. There's places for them to write their answers. And then there's other images. So these images are showing you examples of things, and then they're going to collect more data. So all of these activities are doing lots of things in one place, lots of mathematics in one place. So that's an example. This is a calculus example. Again, it's in the handout that I'm going to share in just a moment. And here's another calculus one, and this one's kind of cool because it is the helix, so it's a screw, and they have to plot some points and find the x-min, y-min, and then they're going to be doing different regressions and graphs. And this one, you'll notice all these little, I call them spider webs, are showing you that these things are connected to each other. So this data is connected to this graph, so as you enter points, they'll show up on the graph. These functions are connected to this graph, and so as they write their functions, they'll show up on the graph. So these kinds of activities have a lot of the preliminary underlying work done for you, and you'll notice that you don't see the image icon anywhere, like how did they get the image in here, and this is because it's all hidden under here. And so that's just an example of an activity already done with the things hidden that you don't want students to see as they're working on it. So you have all of these. This has a lot of different activities, lots of directions and graphing and stuff. So this is a calculus one if you're interested. And I wanted to end with just a fun one that I created in for Thanksgiving, I think, obviously, just to show you, it's fun. So this is 2 pictures. So I have 2 pictures. So you can put several pictures on one graph, right? So this is really 2 images on one graph. Notice that each one, so the turkey is controlled by the slider A, so a variable A, and also the function at A. And what is that function F? Well, here's my function F, which is defined up here. Here's my function F. This is defined. And here it is graphed, and notice that it's hidden. The graph is hidden, so they just hid the graph by clicking this, so they don't see the actual graph, but it is controlling things. But then when you hit the animation, it's not perfect, because this was when I was first kind of figuring out how to do things. If you animate it, it looks like the guy's chasing the turkey with his gun. So just kind of fun things you can do with students too, because they're really having to figure out what functions would help make this work, and how do I make him move that way. And now the turkey's chasing the hunter, which I always think is pretty funny. So that is all that I have as far as this. I wanted to just show you things you could do with images, how you could use it to, curve fit and draw on, and use it to create some cool little fun activities, animations, art, those types of things. So if there's any questions, now would be a great time to ask, and I'm going to put the file with all of the links to these activities in the chat, and it will also be in your follow-up email that you'll get. So I'm going to do that right now. But if there's any questions, I'm happy to answer them.
I don't see any. So if you do have a question for Karen, please throw it in the chat panel.
All right, so I just sent the file. It's a PDF, so hopefully you all have it and you can download it. We'll make sure we give you time to do that. And if there are no questions, then I am done. And thank you so much for joining me this evening. And Amy, thank you for moderating. We hope everyone has a great night and a nice weekend.
And Karen, if you'll throw up the last slide of the PowerPoint, we'll wrap up.
Absolutely. Sorry, I always forget to do that.
I know. So as Karen mentioned, if there are any questions, throw them in the chat panel. If not, we are done for the evening. Thank you guys for joining us tonight. Don't forget, you can register for a free account. Registering for a free account just allows you to be able to save all these documents or save all these papers that we're sharing with you, so that you can use them and you can edit them for your own classrooms or to share with your fellow teachers. And right now, through the end of August, you will have access to the Plus accessories, Plus features, which is, as Karen mentioned, the CAS functionality, so allowing you to help you factor and solve equations and different things like that, as well as the advanced statistics, so looking at distributions and intervals and Z-tests and T-tests and all that stuff.
Right.
And so after August 31st, that will all kind of get kind of locked down for you. But if you're interested, there is a way to purchase that as on a yearly basis moving forward. But 95% of what you are doing on ClassPad.net that what Karen is doing here that you saw today will be available without the Plus account.
Yeah, everything I did today is not impacted by the Plus at all.
Correct. So, so the only thing really is just registering for account with an email address. We do know that there are some people that are having some issues with Google single sign-on, and it could be that because it's a Google account tied to like a school account, there might be some security issues there. But you can still use that email account to sign up for your a ClassPad.net account. And then if you are interested in learning more about ClassPad.net or learning more about our Casio hardware, graphing calculators and scientific calculators, we are doing webinars every Thursday. We are taking a break for next week.
Yay!
So to take a break and to also celebrate July 4th. And so our next webinar will not be until July 9th. And that will be on a graphing calculator on our hardware, or actually our FXCG50.
But also curve fitting.
But and it'll additionally be talking about curve fitting. So taking a look at how you can do some of the curve fitting stuff that Karen mentioned today on like a handheld calculator with images. So then after that, so just follow us on social media to find out about more of those webinars. And as Karen mentioned, we have this webinar recorded, and it will go up on YouTube tomorrow. And then we'll also send you the link in a follow-up email. So I think that wraps it up for us.
That wraps it up. Yep. Thank you so much. Have a great night. And all those links that you see there to YouTube, Facebook, they're all on the document I sent you as well. So.
Perfect. All right. Have a good weekend. Thank you guys so much for joining us.
Good night.